It wants okay, we're going to write inequalities for these interval thingies. If you guys don't remember how to write an interval notation, now is the time to review. Okay, so I'm going to write these as line graphs or x-axis graphs, I guess you could say. I'll put -3 right here and a 5 right here. If I had a parenthesis on the -3 and a bracket on the 5, how would I draw this or write this in inequality notation? This interval notation says something special about -3 and says something special about 5. This is an interval of numbers. It's saying all these numbers between -3 and 5. Now I have a question for you guys. Is -3 included in this list of numbers?
No.
No, it is not. That's why it has a parenthesis. So you would do open circle around the -3. And then what about 5? Is that one included? Yes, and so you do a solid circle, and you would point the arrow that way, you point the arrow that way, and that would be how you do your inequalities. So you want to say that x is what to -3, and x is what to 5. X is what to -3? Greater than. Don't say equal to because it's open circle. What is x to 5? Less than or equal to. So because these are pointing at each other, we could write this as a compound inequality. And to do that, I write x, and then I write -3 on the left and 5 on the right. And the reason why I put -3 on the left is because he's smaller than 5. Can you do it the other way? Yes, but you're a little different if you choose to. Okay, so x is what to -3? What is x to -3 again? It says right here. X is greater than. So we got to put the sign like that. So we would read it as x is greater than -3. X is what to 5? Less than or equal to. So this is how you would write your compound inequality for letter A. Directions ask if it's bounded or unbounded. This is bounded. After we do the next one, you guys will understand what it means when it's bounded or unbounded. All right, let's do letter B. For letter B, it says at -3, that's where we start, we go all the way to infinity. So open circle because it says parenthesis. Open circles, parenthesis, and then we point to infinity. So we're going from -3 to positive infinity. So how would we write this inequality sign? We would say x is what to -3? X is greater than -3. You would not say equal to because it is not a solid dot. This is unbounded. Pretty much, this is bounded. Right here, this one's bounded because we have definitive numbers. This one is unbounded because we are approaching infinity. Okay, all right, next interval, we have 0 to 2. So for 0 to 2, we would have a graph that looks like this. So at 0 and then 2, bracket around the 0, bracket around the 2. So that means a solid dot at the 0, solid dot at the 2, and then we connect the 2 because they're pointing at each other. So what are, how would I write this? Now because they're connected, I know it's a compound inequality like this guy up here. So let's just do this from the beginning. We'll put the x and then a 0 and then a 2. How would I say x is compared to 0? X is what to 0? It is greater than. Greater than or equal to. And what is x to 2?
Less than or equal to.
Less than or equal to. Now if these arrows, these little inequality signs are pointing the same direction, then you're doing things right. And if you go smallest number to biggest number, those arrows should always be pointing to the left. All right, last one, letter D. Let's do letter D. Letter D is, oh wait, we forgot to say if C is bounded or unbounded. What do you think, students?
Bounded.
It is bounded. Bounded. Okay, and then we got letter D. We have negative infinity to positive infinity. Now I know what the book says for this, but I don't like it. I almost never write inequalities for this. I would just say all real numbers. All real numbers, you do a double line and do that, or you actually say all real numbers. Book does something weird. It says x is, I think it says greater than, no, less than or equal to infinity. Don't even write this. I don't like it. Okay, boo. Okay, yay. All right, is this one bounded or unbounded? This one is unbounded because we have an infinity. That's how you do interval notation.